After Chandrayaan-3, India has successfully launched Aditya L1, India's first mission to study the sun. And now here accompanying me is Mr. Venkatakrishnan sir, the former head of Udaipur Solar Observatory. Sir, it's a big day for ISRO as well as the Indian Space Science. So, sir, how important is this mission for the Indian Space Agency and Indian Space Science?
Yeah, it is a very unique experiment which we are now into the initial stages, and this took a lot of planning, and we started off with a very small payload concept, but it grew into this kind of big payload going to the L1. And I have to mention here the contribution of Professor Yuva Rao, late Professor Yuva Rao. He was pushing this project so much, even more than the scientists involved, and I'm sorry that he is not here to see this day.
And also, so there's a miniature model of the whole Aditya L1 mission. Could you please briefly explain the whole process, sir?
Sure.
Starting from here, sir.
Yeah. Here there is a nice setup to show the orbital path what this mission is going to take, and it starts off with a small orbit, and then it becomes more and more elliptical, and finally it is able to escape from the gravitational field of the Earth, and then it goes on and does some maneuvering, because unfortunately we don't have enough rocket power. We don't have the big Saturn rockets. We have the PSLV, so we have to make do with that. So this was designed a very clever way of taking more energy from magnetic fields and then going right into the across to this L1 point, and then making an orbit around this L1 point. So it's a very critical orbit, and we should hold our fingers crossed till we reach there. Yeah.
So this is the L1 Lagrange point where this.
The point is in the the point is in the center, and this is the orbit around that point.
Okay. So, sir, if you could tell us about the observations that will be made by the payload, and how crucial will this information be, sir?
Yeah. So, I don't know whether the viewers can see this. This is the suit experiment, and it consists of a camera which will take ultraviolet pictures of the sun, and probably I have mentioned already the importance of the chromospheric observations. And this is the coronagraph, and here it will take pictures as well as spectral information from the corona. So you will know the velocity and the intensity ratios of different spectral lines in the solar corona. So the dynamics of the mass, the material in the solar corona will be properly documented, and along with this you will be able to see how things build up before any solar storm and before these eruptions take place. So this will be a very useful experiment, and this will also measure the solar magnetic field. Okay. This instrument.
How crucial will this be for the upcoming missions, sir, the solar magnetic field, measuring it?
Definitely, we are, since this mission started the planning very long ago, some of the instruments are, we can say, dated. And once we succeed in this and we get some signals of the solar magnetic field, we definitely want to go and improve. And once we succeed in this mission, this gives both the scientists and the ISRO management to encourage us to go to finer details of the magnetic field.
Okay. Sir, if you could explain to us how this information will be useful for the next Gaganyaan mission, sir.
Yes, that is also a very good question, because Gaganyaan is going to put people in space, and we have to tread very carefully there. So they should not be exposed to any of these radiations from the sun, sudden bursts and storms. So once we have a handle on how to predict these things, we may not be able to, but some kind of prediction, if it is possible, this will help in allowing the Gaganyaan people to take evasive action or protecting themselves when such events occur.
And sir, now that it's been launched, so what's the process like, sir? How long will it take for the spacecraft to reach the Lagrange L1 point? So what's the process like from Earth's orbit to the solar orbit?
I don't exactly recall. What I heard downstairs, somebody telling 300 days, but in some channels I heard 4 months, so I'm not sure really. I have not kept track of that, but it's going to be a long time to reach. I mean, you can calculate with the speed of the satellite, and the distance is several 15 lakh kilometers. So it's a nice assignment to calculate the time required.
Okay, so thank you so much. So that's Professor Venkatakrishnan for you explaining in detail about the Aditya L1 and how crucial the information will be for the Indian space science as well as the next Gaganyaan mission as well. Reporting for CNN News 18, Akshara DM with camera person Riaz.